us again on the show is Seth Fitzsimmons, principal engineer here at AWS. We're going to be talking a little bit about Amazon Location Service. Seth, thanks again for joining us.
Yeah, thanks for having me back.
Yeah, friend of the show. You know how this works. What are we announcing today, and why is it so exciting?
So last time I was on the show, we were talking about the public preview, which had maps, places, geofencing, and tracking. And this time around, last week, we launched into general availability with 4 new regions. So that's always exciting, as well as the ability to do route calculation. So directions from point A to point B. And we added some satellite imagery into the map service.
Wow, first off, congratulations on general availability. That is no small feat here. I'm sure you and the team are very excited.
Oh, it's a massive. It's awesome. It's great.
Yeah, going generally available again, probably getting a bunch of customer feedback during that public preview, but then also rolling out as generally available with these 2 new features of satellite imagery and routing, I think it was that you said. Let's sort of break those apart. We'll go through them one at a time. My coin flip here says satellite imagery first. So what is that? How does it work? I have some ideas, but you're the expert.
Yeah, so satellite imagery, like it's the ability to see your house from space, or at least from an airplane or a drone or something like that. And it's the kind of thing that's really nice to be able to understand what's around you that may not actually be mapped. So if you're looking at your house, you can figure out, oh, there's a fence there. Or if you're going from point A to point B, does it involve going through a swamp? And that's the kind of thing that map data won't necessarily tell you. And it's the kind of thing where it's important to actually go look for yourself. The difference here, so there are more and more satellites getting launched into space, and a lot of them are actually using AWS Ground Station to pull a bunch of the imagery down for processing purposes. We've also got the Open Data Program, but we're still not at the point where you can get a real-time view from space. So a lot of what value goes into this is picking high quality imagery that doesn't include cloud cover. Clouds are the bane of any satellite remote sensing experts existence, particularly in the tropics and places where it just tends to be overcast a lot. So you end up with what's called a mosaic, where you combine images from various time periods of various areas, and often at different resolutions. So you can combine aerial imagery done by a municipal survey with publicly available satellite imagery that's much lower resolution. And the trick is to be able to come up with something that looks pretty good and meets the criteria of not having clouds. And we think we've got that. We're surfacing an imagery layer from Esri. And that, yeah, it includes imagery from multiple years, but it attempts to bias towards modern views as much as possible.
You know, Seth, it's ironic that you run in the cloud, but you don't want clouds.
Yeah, exactly.
But okay. See, if Nick's thing is saying that word that I hate, then my thing is telling awful jokes. So we should turn this into a drinking game someday. But Seth, maybe you can help me understand here. What are the main use cases? Who is, you know? So you talked about the need to get these mosaic images. Like, who is using this feature, and what can they do with it?
Yeah, it's often for people who are displaying an existing map layer where you see the roads, you see the buildings, you see the shops, and you want to be able to show a different view. So sometimes you can show it as a background, or you can just flip from a view that's intended for visualization over to a satellite imagery view, so that you have the opportunity to do more personalized wayfinding, where the computers are good, but they're not that good. They don't necessarily know the most fun way through the park.
Yeah, I mean, if I wanted to go meet up with my friend Shrek over in his swamp, I unfortunately don't think that a lot of modern mapping software would have the expertise that I have, right? But in all seriousness, right, like there's a lot of routing that may not be covered by traditional, baselines, right? For walking, for riding a bike, for driving a car. Maybe you're doing something a little more off the beaten path, no pun intended. You want to be able to have that satellite imagery to be able to figure that out. So Hey, that makes a lot of sense for me.
Exactly.
I'm still holding out for when we'll get U.S. Space One as a new region, but someday when there are more satellites and more cloud and less cloud simultaneously. I don't know.
Yeah.
I'm on a rampage of too many bad jokes, so I'm gonna just cane myself off stage right now. Anyway,
So,
yeah, go ahead, Rob.
oh, yeah, yeah. I was just gonna say, well, okay, that seems to paint the picture for satellite imagery. Yeah. Um, next, we mentioned, so we're launching satellite imagery and routing. Routing sounds really interesting to me. I think I know what it is, but I'm probably wrong. Seth, set me straight.
Yeah, so it doesn't necessarily show you the most fun way through the playground, but it will help you get from point A to point B. And if you want to be able to find directions from, again, your house, because I mean, that's been our existence for the last year and a half, to the grocery store, if you've forgotten, you haven't been because you've been stocking up, um, or you want to be able to help a delivery fleet optimize their deliveries, you want to be able to provide a starting point and a destination point, and you might want to be able to provide various waypoints along the way where you're going to do pickups or drop-offs. And the type of vehicle or not vehicle that you're using is also important. So we have three modes to start with. We have car mode, we have truck mode, and we have walking. And I'll show a demo of that in a few minutes. The main difference between cars and trucks is the size. And trucks come in various shapes and sizes. They have that some are longer than others, some are taller than others. And they have different restrictions. In a lot of cases, they're not allowed to drive on certain roads, or there are overpasses that they're just a little bit too tall for, and you're going to do some damage to your fleet. So, one of the things that I'm pretty excited about on our truck routing is the ability to provide the dimensions of the vehicle that you're actually routing through the world. So what we can do is we can provide you directions that adapt to that.
Man, this sounds really interesting to me and really salient as well as someone who lives in New York, because I don't remember how long ago it was, but there was some truck that went into like the Lincoln Tunnel that was just a little too big. And for anyone who knows what the Lincoln Tunnel is, it is basically if you are behind, right in front of the tunnel, there is no other way for you to get to the other side of the river, and then you're trapped there. And I'm sure everyone has seen on their local news truck drives under underpass that is a little bit too tall, or some variation of this. But I think the granularity here is important, right? You can enter the dimensions of your truck, and then the granularity of the data set that powers those routing recommendations in Amazon Location Service has heights of these various limiting structures to be able to get the exact, ideally optimal path. And I know we talk about this concept of right sizing in infrastructure all the time, and I'm going to draw sort of a parallel here, right? You could say either you're a car and then allow you to drive on any particular road or underpass, but then you get stuck in certain scenarios. Or if you select purely like, hey, I could be an oversized 18-wheeler, then you may forego some more optimal paths along the way. So in my mind, this feature and the granularity from the data enables you to right size essentially the quickest and most optimal path based on that very particular dimension, which I think is really cool. And I think a lot of commercial shippers or anyone who works in that sort of space, this is probably a feature they've been asking for a long time. I don't want to put words in their mouths, but it certainly sounds like it.
When I moved to San Francisco, a few years ago, we lived on a very steep street because San Francisco has those, and there was a large truck that couldn't get there, and what they needed to do was find a shuttle that would actually move stuff from the large truck to our house. So they needed to unload it and put it into the small truck, which had a bit more agility in terms of where it could go. The other thing that I forgot to mention is also you can provide the weight of your vehicle. So bridges have various weight limits. If you've been following the news, you'll notice that some bridges are crumbling a little bit, and maybe the weight limits are dropping a little bit. So yeah, ways to avoid that and keep everyone safe.
So, quick question, Seth. When I see those oversized loads on the highway, where somebody's moving a prefab house and it takes up all the lanes on the highway when it's driving, is that the kind of use case that would be covered here?
Yeah, I mean it's not perfect because the world is large and data is complicated. But yeah, if you have something that is a wide load, you can say, "Oh, this thing is actually 36 feet wide," and we'll attempt to provide a route that will help you with that.
Awesome. And you know, I know you mentioned this briefly at the top, and we touched on this also during the last video when we were talking about Amazon Location Service. But data is hard, is quick, but really to the point, right? It is difficult to implement features like this without really high quality data. And to my understanding, when we spoke, you mentioned that this partnership with Esri and with Here is you know, these data providers that have basically, this is their bread and butter. They really emphasize having high quality, high fidelity, high granularity data. This partnership with them allows us to be able to implement features like this, given some of the I don't want to say undifferentiated heavy lifting, but it is undifferentiated heavy lifting if they handle it on, you know, if that's what they specialize in, right? Why reinvent the wheel?
Exactly. I mean, AWS is just phenomenal at infrastructure and services. So by being able to partner with these experts, we can bring their high quality data with our level of service guarantees. And yeah, it's a fantastic partnership. We're really excited to work with both Esri and Here.
Wonderful.
So,
Now,
oh, sorry, go ahead.
yeah, I was just gonna say, you know, satellite imagery and routing, really the two more prominent features that we see here, or the newest features with the general availability launch of the service. I think it's worth it to at least recap a little bit. What are some of the other features that Location Service has before we go into some of the other applications here of the newer services, or what's new, as well as a demo? Let's just give folks the full picture as quickly as we can.
Yeah, so while satellite imagery and routes they're a bit more standalone, the other services are things that integrate super well across AWS. So we have maps, of which satellite imagery is part of. And that's what you display things on. Places, where you can convert addresses to coordinates to display on maps or use with analytics platforms. You can go the other direction from coordinates to human readable addresses or places, and that'll also get things like venues and businesses and things like that. Routes, which we've talked about a little bit. We also have tracking and geofencing, which are good for IoT services or fleet tracking, and those plug in with geofences. So you can determine when something enters or exits an area of interest, and then it will get published onto the rest of AWS using EventBridge. That is actually absolutely the coolest part of this whole thing for me. I've done some just really neat demos where being able to react to things that are happening in the real world with infrastructure is just really neat, and you can plug it into pretty much anything.
You've talked a lot about these satellite imaging. You know, obviously a lot of map applications and routing applications are very visual. You know, if I were to build a mobile application and I need to render some of this stuff in a native mobile app, is there kind of extended support for that? Am I on my own? Like you talk about all this data, but what does this look like for a developer to try and actually render a map on an application, for example?
Mm-hmm. Yeah, so this is somewhere where we found that customers have existing solutions that are potentially using other data providers, and we want to be able to meet them where they are. So we've been contributing to a project called MapLibra, which is maplibra.org. I think somebody is going to stick a link in chat. And it provides a JavaScript rendering engine for maps, as well as mobile ones for Android and iOS. So we've been working with people there to improve them. The open source project is relatively new, happened around the new year or so, but it's based on years of work by Mapbox on an open source engine.
Awesome. Yeah, no, it's I think there's just, it's interesting, right? Some of these problems can be very pointed, but when you really think about implementing it as a feature in end to end, anything in the location or geographic visualization space, it quickly becomes more than just having the data, or just having a map, or just having then, you know, the algorithm to perform your routing, and by bundling all this together in Amazon Location Service, seems to really be this one-stop shop where if you have anything, I shouldn't say anything, but it is at least AWS's foray thus far into being able to solve for those problems for customers in a way that really is easy and meets them where they are, again, with some of those other visualization tools that have existed in the space, which I think is,
Yeah,
again,
absolutely.
really great.
Yeah, they're independent areas of study around all of these things, ranging from cartography to geographic information systems to logistics. And yeah, we're trying to provide the undifferentiated part. I know one of your favorite words. So
one of
have,
it is my absolute
remember,
favorite term on this show.
Sorry.
We need. I know I joked one episode. We need the days since Nick said undifferentiated heavy lifting on the wall, and I just rip it off every episode because I don't think I've gone one without saying it. But one follow up here from a question in Twitch chat. Oh wait, Rob, what were you gonna say?
Make it happen. I see a blank wall behind you. I don't see the days since Nick has not said that word.
I mean, we'll have to make it happen. We will have to make it happen. I'll crowdsource on Twitter to see exactly how I should implement it. But in chat, 41 Wolves was wondering, can the JavaScript example be used with React Native? So sort of connecting some dots here, could someone use the Amazon Location Service JavaScript SDK to then render maps inside of React Native and make components in React Native with that? My guess is the answer is yes, but Seth, you're the one that has the answer.
It's actually a little bit of a complicated. It's a little bit of a complicated answer. You can use the JavaScript one within a web view to display things. There are some downsides of that. So if you really want to build a native application, there have been a couple efforts over the years, and I'm hoping that we're going to be able to pick some of this up to wrap the native renderers for iOS and Android, so that you actually do get true cross-platform native support. So it's doable right now, but it's not as easy as it should be. And yeah, you can go out and search on the internet for I think it would probably be something like Mapbox.gl React Native. I'm aware of at least 2 projects on GitHub that do that.
Well, I mean, now that we're talking about how to do these things, I'd love to see a demo. Is this a good time to flip open some code maybe and take a look together?
Yeah, sure. Well, let's do that. So I'm going to start with the landing page for the service, just so that you know what you're going to look for when you start getting oriented. This is going to have just some overview information about the service, individual features, pricing, various getting started resources, and then you'll land in the console. And I managed to overzoom that a little bit. And this is where you can manage your resources. We're going to bypass that. We talked about this back in December, or maybe it was February. I can't remember. These years have been days and weeks and time. What is time? Right. So we move on over into the map management. And what I've done here is I've created a satellite map style. So this uses the Esri imagery. That's what the style is here. We've got our ARN, and we know that it's coming from Esri, and we've got a name. And one of the nice things that we try and do within our console is make things as interactive as possible. So by default, you'll get a nice view of Stanley Park. And this is an example of where the mosaic comes in. So Stanley Park itself here, the large green area with the trees, is coming from a different image than the large green area with the boats. And what's nice about this is that you can zoom out and you'll start getting lower resolution imagery from, in some cases, public satellites like USGS or things like that. And let's go back in here. And Vancouver has some nice imagery that was taken by, I'm fairly certain, airplanes. So because of that, we're going to actually go and look at some airplanes. This is Cole Harbor, where the seaplanes take off from. And you can actually see someone here has been preparing for a trip. So it's just kind of neat. This is the kind of stuff you wouldn't get on just a vector-based map. So granted, it is a snapshot in time. You are not getting a live video feed of everything. But yeah, you can kind of see if we go out to the west coast of Stanley Park, we can see people having fun, parking and hanging out and watching the ocean. There's an area out here where last time I was up there, there was a musician sitting on one of these log rounds playing music. So it's just, it's kind of a neat way to explore the world. But it's also a really good way where if you've got some hyper local mapping data, you can drop it on here. So maybe you want to say, I'm having a birthday party and it's going to be on the north end of this beach. And you can drop a marker here and somebody can look at it and say, oh, where's the best place for me to ride my bike and lock my bike up? Because that may not actually be in the underlying data because it's just too detailed. There are some things that images are just so much better for. So that's the satellite imagery angle. I'll flip over to a little demo that I put together using a website called Observable. This is one of my new favorite things. It takes notebook-driven development and brings it to the web. So you're writing reactive JavaScript, and anytime you modify one of the cells, all of the other cells update. And you can create these pretty cool interactive visualizations and exploration tools. So kind of like what you were saying, Nick, about trucks getting stuck in the Lincoln Tunnel. Something that happens really often in the Cambridge, Boston area on moving day is that somebody who doesn't know better takes a rental moving truck and drives onto Storrow Drive, which is right over here, and subsequently wedges it underneath a bridge. So what I'm going to do is I'm going to show how to get from Greater Alston, Brighton downtown using a car. Actually, that didn't route quite right. So let me actually move a little bit closer to Storrow Drive so that we'll force it onto there. So it's going to take one of the parkways. But then if I switch over to a truck, it's going to say, you really want to take the highway. Don't take the parkway. And don't jam it. And maybe it's a little bit longer. In this case, it's 11.4 kilometers. It's again something we can change. We can switch it over to miles, depending on your output. And you can also change the departure time. So you can have it take traffic into account. So if you're going to leave at midnight, that would be very different than leaving at 8 a.m. And then for cars and trucks, you can say we want to avoid ferries or avoid tolls. Tolls are relevant here. And here we have the various truck mode options where we can provide the dimensions of the vehicle in either meters or feet. And we like both metric and imperial measurements. The other thing here, we also have the walking mode. So if you wanted to do that, here's a much more direct route between these things. And you actually, I want to stop at my favorite taqueria over by Harvard. So what I'm going to do is I'm going to right click over here and add a waypoint, and the route will recalculate so that it will allow me to pick up a burrito from Felipe's on my way downtown. And there's, I believe, a link to this into chat as well. The gorgeous thing about Observable is that it allows me to intermingle explanations of what's going on with the actual code that's used. So if you want to see how the map is rendered, you click on the left here and you can say, oh, hey, here's the initialization of it. And it's a really great place to get started if you're going to be building a JavaScript application. So yeah, did you guys have any additional questions about routes that we can use the demo for?
I'm just trying to wrap my head around everything that we just saw because it was just super slick. First of all, we're dropping some links in chat if you're watching over on Twitch to these notebooks so you can fork or copy them yourself. There's also going to be some GitHub links as well. But I think one of the coolest things that we just saw there was, in real time, you're changing the vehicle type from car to truck to person. You right clicked on the map, which adds a waypoint, and then it seemed like near instantaneously we ended up getting a revised pathway here. Under the hood, this is really just the data is not all stored locally on this notebook, and you're just re-rendering it. You're making a call out to the Amazon location service with these new parameters for a new waypoint in the middle between the start and end destination. You're making another call by changing the vehicle type, and all of this just happens so quickly.
Yeah, so the way observable works is that whenever one of the inputs changes, any of the cells that depend on it also end up changing. So if we click into the thing that creates the parameters for the call that actually gets made, we can see all of the different dependencies on other cells on the right-hand side of the screen. For example, if departure position changes, it'll change in here. And that will go back up here, click departure position, and this comes from the map. So what I'm actually going to do, let's jump back, and we'll look at the waypoint positions. Right now, there's only one. If I right click on the map, because I want to walk through MIT and stop at Anastasia as well, we've now got two waypoints in there. And we will see that updated in the parameters. So there are two waypoint positions here. And then the actual call that goes out to Amazon Location Service is right here, and it takes the parameters when they change. So I don't know. I just think that this is a really neat way to prototype things, and also a really neat way to explore APIs like ours.
Yeah, and
Yeah, this is a really cool tool.
I'm just thinking.
What about that? Yeah.
I was just gonna say,
Nick,
sorry,
we're
I
getting
know
worse
we're.
and worse.
I'm just gonna hold up like a big like green sign that's just like I'm talking.
Yeah, we can build something to fix this. Don't worry. Don't worry.
We're
Okay,
going.
I'm gonna take over. Seth, yeah, there's a section that you teed up on the vehicle size. I that was tantalizing. Can we fill that out and see what happens?
Yeah, sure. So what we'll do is we'll say that we have a vehicle that is 15 meters tall. It's one of those double-decker buses you would find in London. And we're going to switch over to the truck travel mode. And it's a little bit of more of a roundabout way, where it doesn't take us across the bridge here, and it takes us across a different bridge over here. So yeah, it'll take some of those things into account. I'm not sure how much that will change. This is actually kind of a good experiment. If we have a vehicle that is a mere 3 meters tall, we do in fact get a different route. Or at least the view changed. I'm not entirely sure what changed, because I had scrolled out of view a little bit. But yeah, kind of thing there.
Now, does this also work if the travel mode is walk?
Oh, if you're a 15-foot tall person on stilts.
Oh, if you're a giraffe.
Unfortunately not. We don't have any walking mode options at the moment. Yeah, I mean, maybe it's like, what is the most scenic way? Or maybe sometime in the future, we can go back to what is the most fun way that goes through the most playgrounds.
I'd imagine, at least with the satellite imagery, you have some of the building blocks to be able to start implementing your own opinionated take on that, given the service here. So it's still possible, just a little more of your own secret sauce there, getting to implement it.
Yeah, exactly. I'm actually, one other thing I want to call out here is that I'm providing some human readable names to the start and endpoint. So we're actually starting from a specific address in Alston. And the way that works is we've got the departure position here. And then we are using the, so we're getting a label for it. And search place index for position actually makes a call out to the places API. This view actually incorporates 3 of the different capabilities of Amazon Location Service. So maps, places, and routes.
Yeah, I think that's a great call out to make.
Fit together nicely.
I personally am a cartographer, and I go out and chart all of my own ventures in latitude and longitude coordinates. But for all of the other mere mortals, unfortunately, we refer to things with human readable names. So being able to plug that in without needing to show up with inputs that people wouldn't be able to come up with themselves, but also not decipher on their own, right? Like, you can give me any latitude longitude pair, and I would not be able to tell you if it is the right location that I'm thinking of wanting to end up. So having that sort of all done automatically through another API call is really, really relieving to me.
So I'm going to use that as a segue to talk about how to call this from your database. Because maybe what you've done is you've actually loaded those GPS traces into a database, or you've got some data set that has addresses and you want to do something that's actually more spatial, or you want to be able to drop them on a map. So what I've done here is I've got a CloudFormation stack that's deployed off of a project on GitHub. There's a, yeah, okay, so it's the Amazon Redshift location user-defined functions, which is in the chat. And it gives me a geocode address and a reverse geocode position function that I can use. So what I'm going to do here is I've got the location of Amazon HQ in downtown Seattle. I'm focusing on an area that's roughly near Seattle and limiting to the US. These are, I mean, it's going to provide better quality results if you say approximately where it is. But then, so it's going to run out. It makes a call to, what is my typo here? Interesting. Okay. I have this elsewhere. One sec. You know, it wouldn't be a demo without some sort of technical difficulty.
Yeah, no worries.
So let's try that again. That looked like it worked. So what it's doing is Redshift is making a call out to a Lambda function that is then making one or more calls out to the Places API. And then it's taking what comes back from that and returning it as a as a JSON string that can then be parsed. Actually, yeah, so I'll reverse geocode something. This is another pair of coordinates, also in downtown Seattle, that corresponds to the Spheres, which is a pretty neat a venue if you've ever had a chance. And General Porpoise is the name of the donut shop within there. So we've got this JSON string here, and using the Redshift JSON functions, what we can do is we can actually extract part of that. So we only want the label component. Okay, let's repaste this in. There we go. And it's made its call out, and we have just a really nice string that can be used to enrich a Redshift table with some additional columns so that you can do some additional types of analysis. And the last thing is if you create a test Redshift cluster, you end up with a few different tables, or I believe they're called dimensions here, one of which is venue, which includes various sports stadiums. So what I'm going to do is I'm going to grab 10 venues from this and combine the venue name, the city, and the state, and then just focus it on what we call null island, which is where things go when they don't geocode properly. It's off the coast of Africa, 0, nice defaults. And we end up getting back this. So the first 3 columns are from the sample data, and then the geocode address is what you get back from Amazon location. So you've got often a name that matches, but then you also have coordinates so you can know where it is. So if you want to use some of the Redshift geospatial functions to combine it with your data to say, okay, I've got a bunch of transactions. What venue were they closest to? That kind of thing.
I feel like you're with a query like this to return a superset or a larger set of a certain matching condition for locations means I could then take these geocoded addresses and then plug them in as waypoints in a route and say, okay, I want to take a route through all of the parks in New York City, as absurd as that would be, right? Mm-hmm. But this actually is in line, or at least seems to be close to a question we got in Twitch, which is, does this support spatial-like queries? I'm not a geolocation expert, so I don't know. Is that a particular type of query that you're aware of, Seth?
Yeah, so spatial queries are show me all of the things that are within this area or that are near this thing. So if you've got a point somewhere in the world, you can find all of the other points that are nearby, or all of the park boundaries that encompass them, things like that. And then you can also do things like spatial joins. So to answer the question a little bit more directly, Redshift has a really good suite of spatial queries, which includes the ability to do spatial joins, as does RDS, RDS Aurora for both MySQL and Postgres. There's excellent spatial support for both. Within Amazon Location, we are much more focused on the location-based service end of things. So we use a bunch of the spatial functionality behind the scenes to do things like geofence intersection, but we take a much more high-level approach to it, where we're not going to provide you the primitives because it's intended to be a more full-blown service.
Right on. I wonder if we could try something. If we pick a coordinate in, say, like the Pacific Ocean, can we try and transcode that and see what label it comes up with? I'm just curious.
Yeah, sure. So let's go back to the reverse geocode position. So if we want to go out, so San Francisco is at about 37 degrees of latitude. So we'll do that. And negative 120 degrees of longitude is about on the coast. So if we go a few degrees out from there, so 126 or so, this will take us out into the Pacific. And I'm pretty sure we're going to get nothing back. We're going to get Pacific Ocean as an answer, which that sounds reasonable to me. I was actually kind of hoping that I would get the Farallon Islands, but I think we went a little bit too far west.
Yeah, that's really cool. So that tells us that, these labels work even for large regions on the globe, right? I mean, maybe there's not a Dunkin' Donuts at that place, but there might be an ocean, and it'll tell you that. That's pretty cool.
Yeah. And even when you do get something like a Dunkin' Donuts back, maybe that's not actually the level of granularity you want. We break those responses out into multiple fields. So if you want to know what county it's in, that's a totally valid thing too, because maybe your point doesn't have as much precision as the specific Dunkin' Donuts.
Yeah, continuing the Boston analogy with Dunkin' Coffee. I love to see it. But yeah, Rob, you were going to say something.
Yeah. One thing I was wondering is, so let's say I'm building an application around this, right? And I want to. There's a lot of different kinds of applications out there that use maps as a component, and I wanted to overlay that, right? I wanted to render like, hey, I wanted to highlight this region as this is where a trail is, or this is the state. These are the state parks, and I wanted to just imagine I take the satellite imagery, and I just want to highlight, hey, like here's the extent of this state park, and you zoom out enough, and here's the extent of that state park. I want to render that, and I want to make sure that it stays in sync with the zoom level of the underlying image. How would I go about doing that?
So that's actually what's being used to render the route here. The route geometry is coming back from the routes API as a line, and then it gets converted into a pair of markers for the start and end. So if you just want to like mark dots on a map, but then it also comes back as a set of legs, which can get converted into a geometry. So we have three features here because there are three legs between each waypoint. And if we open one of these guys up, we'll see that here's a feature. It's got a line string with a whole list of coordinates. So this is the raw data. And then we've also got some properties on it. So we know how long that particular leg is and how long it'll take to traverse it. Once that's done, we add it to the map by wrapping it in a Geojson feature collection, and then setting the data on one of the source layers in the map. And then it also zooms the map to fit that. So let me actually show you where that data layer is defined. That's in the map here. We've got the source. So it's a Geojson source. So things need to get converted into that format. It starts with nothing. And then there's also a layer, which is what's used to actually display it. And the source is the route source. So it pulls from here. And then it uses route style to actually determine how it should look. So in this case, we're saying that I want to display a line. I want the connections between things to be round, and I want it to be hot pink. So if I change this to lime green and then reevaluate, we now have a lime green route on the map. So you can do the same thing with points. You can do the same thing with polygons. And as I zoom the map, it gets synced in with the base layer. So it's part of the rest of it. If we wanted to, we could actually move it below the labels, which is a little bit of a pet peeve of mine. Most maps should put the labels on top because that's the important part. In this case, we're actually obscuring it. Yeah, so you can change the layer ordering of things. This is why the map rendering angle is so important. And a lot of companies have a lot of investment in that already.
I see. So we should be able to, if we kept playing around in this notebook, we should be able to create a geometry and have that render in the exact same way that this route is being rendered, and we can then set a layer where it's appearing either above or below the labels, and then that'll stay in sync with the zoom of the zoom level of the map as well. I saw some of these opinionated data structure like the Geojson and some of this stuff. Is this all coming from MapLibra or is this a standard?
Geojson's a kind of a community-led standard that's been around for over 10 years. It is a proper RFC now. So it's a full-blown standard. And it's a JSON representation of, I guess, the way that people model geometry. There's an organization called the Open Geospatial Consortium, which AWS is a member of, and they define things like how do you describe a point? A point is between 2 and 4 coordinates, depending on the number of dimensions, and it has a bunch of different encodings. So you can encode it as a well-known text string where it's just a point and then your coordinates. There's also binary representations of that and JSON representations of it, which means that if you have a JSON parser that works, you don't need to actually worry about parsing the string out, and you just get a list of stuff back that can get displayed.
Yeah, I just for some edification for Twitch chat, when we talk about these standards bodies, when there's two divergent images. One is like a bunch of people standing around asking the philosophical question, "What is a point?" And that seems like that's the interesting part. But I would say that based on my experience in these standards bodies, that is only 1% of it. The rest of it is very, very mundane. Like, oh, okay, well, what about this encoding? What character set are we using? What about this case? What about backward compatibility? So it is not it's hard work. It's necessary work. Standards bodies work. It's a very interesting thing if you want to. It's a whole other world that you can disappear into. So. But yes, thank you for explaining that.
Yeah, well, and actually, if people want to get a little bit more into it, there's the OGC world of geometry. But then if you start working with OpenStreetMap, the way that models the world as geometry is totally different. And you can get the two to speak to each other, and they both have pros and cons. But it's just there are different ways to look at it out there.
Awesome. Well, I think most importantly, we did not go off and create our own. I think that we could all probably agree on that.
Yes.
We chose open standards that communities are using that have other tool chains that are built on them, like MapLibre and MapLibre GL and some of the others that I saw shown before. So, hey, Seth, this was awesome. Again, I know we had you on the show not too long ago, but it's a rapid pace of innovation here. For folks that want to check out some of those observable notebooks, we've dropped some links in chat. We'll try to drop them in again. But anyone who tuned in today that wants to get started with Amazon Location Service, where should they look?
They should probably start on aws.amazon.com/location. That's going to provide all of the overviews for the service. We've got some videos on YouTube that show how to do various things. There's a channel with at least 3 videos up now. And if you're already an AWS user, click around the console. We've done as much as we haven't done as much as we can. We can always do more. But we are really happy with what we've been able to do so far to make the console as interactive as possible so that you can explore things without having to necessarily drop into your own applications right away.
Awesome. Well, love the demo. Super clear and crisp explanations there, Seth. And I definitely have to check out Observable HQ. That looks like a really cool way to play around with some code and some samples. Nick, anything else we wanted to cover before we close out the show?
No, I think we're good. Seth, again, friend of the show. Thank you again for joining us. Seth Fitzsimmons, tripping over my words. Seth Fitzsimmons, principal engineer here at AWS, talking to us again about Amazon Location Service going generally available and some of the newest features in satellite imagery and routing. So Seth, thanks again.